AI isn't making programmers stupid, but it is making us worse at our craft. And more importantly, the way a lot of us are using AI right now has the potential to shoot us in the foot in the future.
ChatGPT is down, and I don't know about anyone else, but I have come to the conclusion that I can't use my own brain anymore.
Because if you outsource the hard thinking to AI, your critical thinking and problem-solving skills start to atrophy. And if you keep accepting agentic output you don't understand, you'll slowly fill your codebase with looks-right code that fails in the real world. It's not immediate, it's a slow leak.
Not only is technological improvement not new or special or novel, the observation that technological improvement will make us dumber is also an ancient observation that we seem to have forgotten.
Okay, let's start with the real problem. The issue isn't that AI writes code. The issue is what AI replaces. Thinking. The thinking that builds your instincts. Because real engineering isn't about how fast you can code. It's about how you can predict how things will fail. And when AI consistently removes the friction, the stuck moments, you get fewer opportunities to think about the hard parts. There's a term for this in cognitive psychology. Cognitive offloading. It's basically when you rely on tools to carry mental load for you. Memory, attention, problem solving. So your brain doesn't have to work as hard, which can be great until you never practice the work anymore. And there's another term from human factors research, automation bias. That's the tendency to overtrust a confident automated suggestion, even when it's wrong. If the UI looks clean and the answer sounds plausible, our brains can go to, yeah, sure, let's ship it. We already do this by rubber stamping lengthy PRs that seem to work. And those two things together, cognitive offloading plus automation bias, are the recipe for skill drift. Now if you layer on incentives, deadlines, performance reviews, which often hinge on output quantity, and the fact that AI is right there, ready to give you a full solution in 30 seconds. This isn't a moral failing. This is a predictable systems problem. Okay, so here's another thing. The 10x productivity promise. I feel like the last here has been nonstop hype.
Now, this undercuts a core Wall Street narrative that AI will simply just supercharge white-collar efficiency. The payoff may be more uneven than the hype suggests.
You can use it, but you have to check it. And sometimes people are so exhausted from checking it all the time. They're like, I'd rather just write it myself and be able to trust it.
I just haven't seen the 10x improvements that we were promised. But what I have seen is that AI speeds up scaffolding, boilerplate unit test generation, and first pass implementations. And by the way, maybe we shouldn't automate the creation of tests, but that's a topic for another video. But shipping speed is constrained by all the stuff downstream. We optimize locally. I wrote more code today, but globally the outcome is not we ship 10 times faster. Sometimes the outcome is we merged twice as much code today and now we're spending 3 times the time debugging, reviewing, and cleaning things up. So if you feel like you're moving faster, but are also feeling more fragile, you're probably right. You're just seeing the difference between code generation and engineering. Now here's the part that hits people, learning. Similar to tutorials, AI makes it feel like you're actually learning. But a lot of the time, it's not actually happening. Tutorials, to use that example, are kind of like junk food. You watch a 20-minute video and you feel productive. And then you try to build something alone and you're like, wait, I know the words, but I don't know the thing. Real learning happens when you get stuck. That stuck phase is where you build the mental model. AI removes the stuck phase, which feels amazing and productive, but if you're using AI to solve every roadblock the moment it hits you, do you ever really learn? Or are you just getting better at prompting and vibing? If the tool consistently removes the hard parts, you get fewer reps of the hard parts. And we've seen a version of this before. Pre-ChatGPT, where we all just kind of copied and pasted things from Stack Overflow. But even then, you still had to fight the problem a bit. You had to adapt the snippet. You had to figure out where it fits. Now you can just prompt for a full implementation and it'll even explain it with bullet points like it's doing you a favor. And you're like, wow, I totally understand this. And then when it's actually running with all your other code, you realize you don't. You missed something. LLMs are great at plausible code, but plausible is not the same as correct. And the risk isn't just bugs, the risk is hidden assumptions. Because the model doesn't know your real constraints unless you tell it. And if your context window fills up, the model can forget things. So it fills in the gaps with assumptions that follow a standard distribution of its training data. And that's how you get code that looks right. Code that compiles. Code that passes a quick smoke test. Code that works on a happy path. and then breaks a dependency that wasn't included in the context. This shows up in a bunch of research directions. Benchmarks and evaluations show that models can produce code that passes superficial checks but still fail on edge cases. And security-focused analysis repeatedly find that generated code can include insecure patterns or incorrect API usage, especially when prompts are underspecified. And here's an important nuance. Benchmarks like Human Eval, which evaluates the capabilities of code generation in models, are mostly small function level problems. They don't capture the real pain. So if a model can pass some benchmark, that's cool, but it's not a guarantee it won't quietly poison your code base and your brain with almost correct. Now zoom out from the individual to the team, because this doesn't just change how you work, it changes how the team works. When AI is everywhere, code reviews start becoming vibe checking. You stop digging, tests become performative, or get skipped because we're rushed. Ownership gets fuzzy, because nobody wants to say, yeah, I don't fully get that part. Again, debugging gets slower because nobody has the true mental map of the world. You can't debug what you don't understand. And automation bias becomes a team multiplier. Once trusting everything becomes the default posture, bad suggestions slip through more often, and people get less rigorous over time. So the cultural decay isn't we got lazy, it's our verification habits degraded. You know what happens next. Incidences, hotfixes, rollbacks, security issues, and a bunch of backlog tickets that say we should really refactor this, but nobody touches it. So what should we do? Because I'm not saying don't use AI, but we need rules, like real, boring, adult rules. So here are 3 principles that I think keep AI as a superpower instead of turning you into a passive dummy. So number 1 is accountability. If you can't explain it, you don't own it. And if you don't own it, it shouldn't be merged. This is where people get burned. They accept agentic output, it passes CI, and they never build the mental model. Then it breaks. They're stuck debugging a system they didn't design or don't understand. If it's hard for you to understand it without building it manually, lean into building it manually instead. Verification is a habit. AI output is a draft. Treat it like an intern, a smart intern, a fast intern. You verify like it's untrusted until proven otherwise. Try to break it. This directly counters automation bias. High trust plus low verification is when we get complacent. Preserve your thinking opportunities. Boilerplate? Great. Scaffolding? Great. Generating test ideas? That's awesome. But architecture decisions, security critical logic, unfamiliar domains where you don't even know what questions to ask, that is where you should slow down, and you might consider just doing it by hand. Not because you're trying to prove something, but because you're training the part of your brain that keeps you in the organization valuable. So here's a practical workflow that I recommend. Before you merge AI written code, you should be able to answer these 3 questions. 1. What assumptions does this code make? What is it silently assuming is true? 2. How did we verify it? Not it compiled, not it passed a happy path test, but how did we verify the failure modes? And 3. Can I explain it to another engineer in 2 minutes? If not, that's your signal you're outsourcing too much thinking. And yeah, this adds time. But the catch is, it saves you time later. Because you're either paying now with thinking or paying later with incidences. Now let's go up another level. Industry risk. Because this isn't just about your personal productivity. If the average developer gets fewer reps over time, we produce fewer engineers who can debug deep problems, and seniors get pulled into constant AI output cleanup. We're not losing jobs first, we're losing competence first. So if we collectively get complacent, we don't end up in a world where AI replaces us. We end up in a world where software just gets more fragile, and teams will focus their hiring on engineers that can think in systems over the vibe coders. AI isn't making programmers stupid, but it can make us weaker if we let it replace the hard thinking. So use AI, but stay accountable, verify aggressively, and preserve your thinking opportunities. And I want to know if any of you feel like this. Have you caught yourself rubber stamping AI output you didn't fully understand? Let me know in the comments. All right, go build something solid.